Hey everyone, thanks for watching How To Pixel, and in today's video, I'm going to be showing you the behind the scenes of this entire panel and how it's built. So, let's start the video. So that's right, today we're talking about this massive beast of a screen. This is probably the biggest thing I've ever put in the light show that we'll be using this year, and it is so cool. I have all of the stats on it, the size, how it's all put together, everything about it. And in another video, I'll be showing how to set up the software end of it. But just for today, I'm going to show you how the entire thing is built. So first, this panel is made out of P5 panels. If you didn't know, there are two common types of panels that people use. There are some other ones, but the most common ones are P10 panels and P5 panels. P10 panels mean there are 10 millimeters of space between each pixel, and P5 panels are 5 millimeters between each pixel. So P5 panels are more dense, they have more pixels in them, but they're also a bit more expensive. If you want to build a screen just to put text on, maybe a few designs, P10 panels should work out fine, but if you want to play videos, I'd really recommend you get P5 panels, because since there's more pixels, it can make the image show up better. So there are P5 panels in here, and there are 7 panels across and 8 panels up and down total. This is what one single panel looks like, and there are a total of 56 of these panels in here. Like I said, there's 7 across and 8 up and down. For each P5 panel, there are 64 pixels by 32 pixels within this one panel. This is a P5 panel, like I said. If you have a P10 panel, then there would be 32 pixels by 16 pixels. It'd be the same size, just with less pixels in them. Here is the back side of a panel. You have your data in here, your data out there, and then power is plugged in here. The way you can tell the input and the output separately is it says J in right there above the connector, and this one says J out. There's also arrows on the panel, so you can tell your controller which way the arrows are facing. Usually most people put them up, and then you tell the controller that the arrows are going up, but you could have it down. And then if you buy the panels, you should buy these ribbon cables. Some panels might come with them. These plug right into the jacks right here. They're keyed, so they can only go in one way unless you push them really hard. But they can only go in one way, and they fit in there, and now this could connect to the next panel in line. And then you can also get longer ones to connect these to your controller, but when you're going from panel to panel, you only need these short ones. These are the power cables I got with my panel. This cable could power 2 panels, and there's a power and a ground, so off of one output, it could power 2 of these panels, and you just plug these in with the little clip facing the wall of the connector. You push them in, and you hear a little click, and then they are in there, they can't come out. Now this panel has power, and if I plugged in the data to a controller, it would have data as well. You'll also notice these panels have screw holes in all of the corners and also in the middle, and this is what allows us to mount them all together to make one big panel like this, and I'll show you how that looks on the back side of it in a little bit. So this is what each panel looks like inside of this entire panel, and since there are 64 pixels in each one of these and there's 7 across, there are 448 pixels total across, 448 pixels wide, and then there are 256 pixels up and down height-wise. And that makes for a total of 114,000 something pixels in here. I'm not sure of the exact number, but there's a little bit more than 114,000 pixels total. So with a 7 panel by 8 panel screen using P5 panels, this gives you a resolution of a little bit higher than 360p, I think. Data-wise, this thing takes 675 universes of data. So when you set this up on Xlights or whatever programming software you're going to use, it takes 675 universes, and it takes 344,000 channels. It's not that exact number, it's a little bit more than that. If you have a different size panel with like P10 panels or P5, just not the same size as this one, it will be a different number of channels and universes for you. Now going back to the individual panel, there's a few other things I want to talk about each panel. These panels are the indoor panels, so we had to make a complete protective box because if these get wet at all, they will break. You can buy outdoor panels, but they're a lot more expensive, especially when you're buying 56 panels. And they aren't even fully waterproof. Only the fronts of them are waterproof. You still have to waterproof the back part of it. So that's why I decided to go with indoor panels. It was cheaper to build this whole box than buy waterproof panels, but still have to build a box to waterproof the back of them. Each panel with all of the lights on white and at 100% brightness takes 2.38 amps DC amps. These are 5-volt panels. I think almost all panels are 5 volts, but it takes 2.38 amps on 100% white. And that's when you're running it with a color light card, which is what I'm using. If you have something else like an Octa-Scroller, or you're running the panels right off of Raspberry Pi, I heard that they take a little bit less power because those computers cannot make these fully bright. Now, if I was to turn on this whole panel, each LED white at 100% brightness, it would take a little bit more than 133 DC amps. And at 5 volts, that takes 665 watts of power on the DC side. Since these panels use DC power, you have to have a power supply in the back of them to convert AC power from an outlet to DC power for these. I'll get into what power supplies I have in the back in a second. But now I'm going to talk about where I got this panel from, how much it was, and what came with it. All of the electronics parts came from Wired Watts using their Build a Panel Kit tool. If you go on Wired Watts' website, they have a tool where you can build your panel and it'll tell you all the parts you need, how much power it'll take, what the resolution will be, and then you can order all of that stuff right there. So the kit came with a total of 62 panels. I only needed 56, but you could choose for them to send you extra panels just in case some of them break. And I did actually have some of the panels break. These panels are very breakable on the corners. If you look, there's this little cover on the front, and on the corners, it breaks when they start rubbing against each other. So you have to be very careful with that. And on this panel, even right here, you can see it right there, the pixel is missing. Now, this panel still worked, and all of the lights worked except for that one. But it was just annoying that we put the whole thing together and then this pixel was broken. But thankfully, I had the replacement panels, so I took the panel out and replaced it. And this actually happened 3 times. There were 3 pixels that broke. So you have to be very careful not to bump the edges because you can easily start peeling this protective stuff off. I could just pick the corners off. So make sure you're very careful with that. Another thing is, if you don't order extra panels and you do have one break and you want to get a new one for it, you have a chance of the panel being slightly different colors than the rest. Because in the factory where all these panels are made, they take a ton of them and test the colors at once and set all the settings inside of them to know which colors are which. And if you get a panel from a different batch, those could be set to slightly different colors. So that's why you should order extra panels the same time you buy these panels if you don't want the colors to be a little different. So it came with 62 panels. The other thing it came with was a color light 5A-75B panel card. This panel card can be run by Raspberry Pi running Falcon Player, and that Raspberry Pi can also run other controllers at the same time. I've done some testing. I can run this whole screen and my Falcon controller off of one Raspberry Pi. The color light card has 8 panel outputs, and it can run 8 P5 panels off of each chain for a total of 64 panels. I think you can run more if you have P10 panels, but I'm not 100% sure. It also has a 2-port switch on it, kind of like most Pixel controllers do, so you can have your data input come in one and then output any other data you have for the rest of the panels. This whole panel is run by that one card. I've seen some people use 2, but I was able to get 1 card to work for all of this. I will have a separate video that talks about how to set up the color light card, all of the software settings, because there was a lot of problems trying to set this up and it made me want to pull my hair out. But I don't want this video to be super long, so that's a whole nother video I'll make another day. So it came with the color light card, and it also came with 3 Meanwell power supplies, 5-volt Meanwell power supplies. Each 5-volt power supply can output up to 60 amps of DC power. So if you put all 3 of those together, it can output 180 amps total. This takes 133 amps if it's on full bright white, so I didn't have to worry about there not being enough power. Plus, I'm probably not going to be running this at 100% white. It's very bright. You can also select to save some money by getting the generic power supplies, but I recommend getting the Meanwell ones because they have a lot of safety features inside where if they start overheating or something's connected wrong, it will just completely shut it down so you don't start a fire. Whereas the generic power supplies, I don't think they have as many features as that. So for an extra $10 for each power supply, you know that you won't have a fire started if you connect something wrong. The next thing it came with was all the connectors you would need to hook them up. It came with a ton of these with like 12 spares after I connected them all together. These are the ones you use to connect each panel to the next panel. And then it also came with some longer ones, so at the end of the chain, which is more in the middle of the panel, so these short ones wouldn't be able to reach. It then also comes with all of the different power connectors, so you can get power to every single panel. There were some spares of these too, so I didn't have to worry about any of them breaking or losing any of them. But one problem is the panels are not fused, so if something was to happen past the power supply that the power supply can't take care of, you could just break the panel because they aren't fused. Whereas with your Pixels, most Pixel controllers have fuses built into them, so if something happened, it would blow the fuse and not blow the Pixel. So Wired Watts sends these fuse boards with the kits, so you can have all of your connections for the panels fused, and since there are so many of these plugs that you can't fit them all on a power supply, you'd have to hook a bunch of them together into one power supply. These can give you more power jacks off of one power supply to be able to power everything in here. They sent me a total of 7 of them, and I plugged 4 of these into each one of them, and then they could power a total of 8 panels because each cord has 2 plugs on the end. Then those fuse boards are plugged into the power supply. There are 3 fuse boards on one power supply, then 2 fuse boards on one power supply, then 2 fuse boards and the color light card on another power supply. I think they have 7.5 amp fuses on them, but I'm not fully sure. I'll put it on the screen what size amperage they are for each of the fuses. The kit also came with wire to connect from the fuse boards to the power supplies. The only problem is Wired Watts sent wire that was way too big to fit in the power supply and in the fuse boards. I think it was 10 gauge wire. It could barely fit inside the power supply, and it could not fit at all in the fuse board jacks. They're just too small. So I had to go get some smaller wire to go between the fuse boards and the power supplies. And then it came with 2 AC cords to plug into the power supplies. Now you might be wondering, if there's 3 power supplies, why did they only send 2 AC cords? Well, you can run up to 2 power supplies on one AC cord, as long as the AC cord is big enough to handle the amperage. So 2 power supplies are on one cord, and then another power supply is on its own cord. I have seen some people use 3 power supplies on one extension cord, but I've heard you should only do 2, so I'd recommend only doing 2. The only problem is, the AC cords Wired Watts sent were way too small. They were 18 gauge wire in the extension cord, and it might have been thick enough, but I didn't trust it, and my dad didn't think it was a good idea to use them. So I had some other extension cords that I used and put those in the power supplies. And I reached out to Wired Watts to let them know about the cables going between the power supplies and the fuse boards and these AC cords. And I haven't gotten an email back, but I did send that to them just to let them know. And then the final thing this kit came with was mounting brackets to mount all of the panels together. The brackets go up and down between each of the panels. There's a total of 6 of them for the middle panels. And then for the panels that are on the outsides, they have a separate mounting bracket, and that one has bigger holes on the side of it, so you can screw it into whatever you want to, and I'll show you that in a second. And that is everything this whole kit came with. It also had the option to add on a Raspberry Pi for an extra price if I wanted to, but I already have enough Raspberry Pi, so I didn't get one of those. And now for the moment you've been waiting for, the grand total of how much this panel cost. This does not include any of the building parts like this box or the wheels or the cover for it. This is just the panel and the hardware such as the power supplies and the wire and the controller. This is just the price for that. This was ordered in February of this year, 2023, so the prices may have gone up since then, but at the time it was $1,680 for the panel and all of the things I talked about, not including the cover or the box. So yeah, this thing was pretty expensive. If you ordered P10 panels, which are the less dense panels, it would have been cheaper, but I wanted to be able to play videos on here and not just text. The P10 panels are better for using words, text, maybe some designs, but if you're trying to play videos on here, they might not come out as well. And then these are the indoor panels, like I said, so they're cheaper. If I was to go with the outdoor panels, the price would have jumped from $1,600 to $2,300. So it was way cheaper to build this frame for it than get the outdoor panels, and I really recommend you do that too. Now for the entire frame part of it, I don't know the exact price, but I think it was somewhere between $200 and $300, so not that bad. And now the last final thing I want to talk about the panel before I move on to the frame is the sizes of it, how long, how wide it is, for anyone who's curious about that. The actual screen size, so not including the border, which is about this much from the edge of the screen on both sides, and same on the top. So the actual screen part with the LEDs is 88.25 inches wide, and then it's 53.25 inches tall. This is just the panel size going from edge of the panel to edge of the panel, not with the frame. Now, if you want the total size of this box, including the frame, all of the sides, it is 92.75 of an inch long. So going from very edge to edge of the panel, and then going from the top up here to the bottom of the panel right here, it is a total of 55 inches tall. And then the widest part of this is the total distance between the edge of that board over there and the edge of that board over there where the wheels are on. That is 97.5 inches wide. So this whole thing would need a space of 97.5 inches to be able to fit. And then the total distance from the ground to the top of the panel is 76 inches. The panel is a little bit less than 21 inches off the ground. This panel is going where a projector used to be, and I wanted it to be high enough so everyone can see it, and if it was too low, the snow would start to cover it, but I couldn't make it much higher because it wouldn't be able to fit under our garage. And then if anyone's wondering the weight of this, each individual panel is pretty light. This is less than a pound. I'll put up on the screen how much it weighs. But when you get all the panels together, it's pretty heavy, and when you add the entire size of the frame, it is extremely heavy. I don't know the exact weight. All I know is it usually takes 2 people to move this. It does have wheels on it, but it takes 2 people to move it, especially because there's nothing supporting it on the back. So if I didn't have the boxes that I have behind here right now, this thing would just tip right over. And that brings us into the frame part, and I'm going to talk about how we came up with this frame. Some of the things I do different if we could rebuild it again. So first, all the mounting brackets had a little bit of room, I'd say about this much, maybe a little less, coming off each side of it. That way you could screw it onto something. But that's what you use to mount it to something. So what we did is we built the first part of the frame, which is this little border that went around the entire panel. And you can see it goes up here. It's a little bit of distance between the very top of the frame and the top of the panel. It looked like this when we were building it. We measured out the entire size of just the panel, so we knew how big to make it. And height-wise, it was just slightly too small, but we were able to get it to fit in there after doing some working around. So it was actually kind of perfect because it held the panels in very well. Now for width, we had it maybe 1/8 of an inch too long, so there's a little bit of a gap. I'm not sure if it's on this side. I think it's on the other side over there, but it's not that big of a deal. You can't see it at night. So right here, the mounting brackets sit against this, and I'll show it when I show the back side of the screen, and it's screwed into this little border right around here. However, the panel was the very last thing we put in here, so we put the entire frame together first. So I'd really recommend you put in the panel last, since it's very heavy. And then this border that goes all the way around the panel is then screwed into this board right here. So this board is a total of 1.5 inches from the very edge of this board right here to the edge of the panel. And that was plenty enough to get the Wired Watts mounting brackets to work on here. Then the next thing we have is this board right here. This is a 1x6. It's 6 inches wide. It's actually a little bit less than an inch thick. And it was 6 feet long total. We cut some off of it, and now the total length of this is 53.5 inches long. So then the board that goes around the border of the panel is screwed into this board right here. We screwed into the side of this board, and it went through here into this board, and there's about 1/2 inch of space between this board and the rest of this board, and that left for enough room in the back side to be able to fit all of the power supplies and the controllers and still be able to put it back on. So this board goes around the entire border of the screen screws into this, and then this board is screwed into the 1x6 right here. Like I said, make sure you put all of this together before you put the panel in, because it's just a pain if you don't. Now at the top, it was the same way, and you can actually just barely see right there above my finger, there's a little hole, and that's where the screw went in to screw this board into the main board. And this whole board goes across here we have the border board screwing into this, and at the edges, we actually made it stick over a little bit more. First, because when we put it on, we need to know how much to cut. But then we thought when we left it over like that, it might actually be good so rain and snow doesn't drip down the side. So we left a little bit sticking off the edges right here. And I'm going to put my phone down so I can measure the total length of this board. So this main top board up here, including the part that sticks over, it is 96¼ inches long. And then this board right here, the border board, as I'll call it, is 88¼ inches long. This board goes, the left side goes all the way up to the top, and this part starts here. It doesn't go all the way over. If I zoom in, you can see right here that this board actually ends here, and the left board goes all the way up to the top. However, I don't think that really matters as long as you get a good border around the panel, and then you can screw it into here, and it's sturdy. That should be fine. Now moving on to the bottom, we have the same board down here. It is a 1x6. And it ends right where this part starts. So up there, it hangs over a little bit. But right here, it ends to make a perfect square. And then the border board is screwed into the top of it like the rest. And it goes all the way down here to the side. And on both the left and right side, this board is in the middle. And the top and the bottom overhang it down here. So for the entire screen, we have the border board that goes around the whole panel. The panel screws into that. But before you screw the panel into that, the border board is screwed into the main part of the frame around there. Next, I'm going to talk about these legs. These legs have a really big problem, like I said earlier, and that is it only supports it on the front. There's nothing on the back side. So as soon as you let go of this, and if it's on the slightest bit of a slope and nothing's behind it, it falls backwards, and if you don't catch it, this whole thing will probably be broken. And the reason we didn't put anything on the back is because we wanted to butt this all the way up against the garage. So when it's against the garage, there shouldn't be a massive problem because the garage will be able to save it. And we have one other thing, safety feature, so it can't tip over, that I'll show you in a second. But we have the frame on the front so it can't tip forward. So what we have is this 2x4 right here screwed into the side. It goes about halfway up the side of the panel, and then it goes down into the frame right here. It screws into another 2x4 right there that goes down and it's flat. And this other 2x4 is what gives it the support so it doesn't fall forward. And then on the bottom, we have these two wheels that can fully rotate around. And they have brakes on them. I don't remember how much weight they could hold. I want to say they're either 40 or 60 pound wheels, but they are still working fine right now. The wheels are probably about 3.5 inches tall. And the only problem with them is, since there's smaller wheels, if they hit any bump like this floor, there's a lot of holes in it. They get stuck in it and it's very hard to get it out, and you almost have to lift it up. So if I was to rebuild this, I'd probably get bigger wheels, just slightly bigger wheels. But they're not a huge problem. It's just a little bit difficult trying to move them around. And then this is the exact same on the other side over there. One other thing I forgot to mention is all of these pieces were bought from either Home Depot or Lowe's, except for this front part, and that's what I'm going to get into now. Now, the front protective part that protects the panels from getting wet, this was the hardest part to get on here. It was such a pain, and I do not recommend you do it the way we did. But I'm going to tell you the way we did it. So we saw a video of a guy who built a panel like this, and he used plexiglass for the front of it. And what he did was, he put a little hole on the side of the board so he could slide the plexiglass down from the top up there, and then put the top on once the plexiglass was on here. But we were looking around for plexiglass to fit this size, and we were looking at almost $500 for a piece of plexiglass. So we found this stuff. I'm not really sure what it's called. I will put the name on the screen. This is a smaller piece that we cut off of here. We bought a big piece. I think it was 8 feet by 8 feet, but I don't remember exactly. It actually might have been 8 by 6, but I don't remember. We bought this off of Amazon, and our thought was we could put it on the front and then do the same idea with the holes and slide it into the holes. Worst idea ever. This stuff stretches just slightly. We couldn't get it to fit in the hole. It kept falling out of the hole, and we actually only ended up getting it to fit through one hole, because as soon as we'd get it through one side, it'd fall out of the other side. So what we had to do was staple it onto the border board, hope we could stretch it out as far as we can, and then we put silicone around the entire panel, and we also put silicone on the staples so no water can get through. So I think this stuff was a really good idea, but just the way we executed putting it on here was very bad, trying to get it to fit in holes like that. But if you don't have the money to shell out for a giant piece of plexiglass, this is definitely the way to do it. And I think Boscoyo even sells this, so I'll put it on the screen and I'll put a link in the description for this. And this stuff, if you're curious, is a 1/16 of an inch thick. So that is the entire front part of the panel. Now I'm going to spin this around so we can get a look at the back side. So all we did was put 2 pieces of, I think it's plywood, and the reason we couldn't use one long piece is because since this panel is slightly over 8 feet long, it will not fit, so we had to get 2 different pieces and cut them and merge them together, and they are screwed all around the top onto the 1x6 boards right here, and they go all the way down, screwed all the way around. And when it gets to the middle where the 2 ends meet, they were not perfectly cut to smush together. There's like little cracks, so we took a piece of duct tape and ran it down the crack just so nothing can get in there. And there are also screws behind here because we have a board that's in the middle of the panel, so we'd be able to screw this in here. And we also have vents in the back, that way the heat can be vented out, and I could feel the heat coming out of here just putting my hand there. These vents we also siliconed and put them into the board, but there isn't really anything else to the back of this. Now, before we put the back on this a month ago, I took a video of the entire insides and all of the wiring so I could show you that, because the best part of looking at a panel build is seeing all the wiring in the back. So over to you, Past Nick. What's up everyone, Past Nick here, and I'm going to be showing you the back side of the panel and how everything works. First off, we have 3 power supplies, 3 5-volt power supplies. All 3 of them are from Wired Watts. There's one there, there, and there. Now, obviously, all these power supplies have to go to an extension cord to be plugged in. And from what I've heard before, you can only have 2 power supplies, up to 2 power supplies on one extension cord, and you shouldn't do more than that. So because of that, we decided to put 1 power supply on its own chain, and then these 2 over here are on one chain. So there are 2 extension cords down here that have to be plugged in to get this to work. This one powers the color light card and the first 2 columns of panels, and then this one powers the other 5 columns of panels. Over here is the main brains of the system, the color light card. This color light card can run, I think, up to 8 panels on one chain if they're P5 panels. And don't quote me on this, but I want to say 16 if they're P10 panels. I'm not fully sure, but to quickly overview it, there's 2 Ethernet ports at the bottom. Kind of like with most Pixel controllers, how it's a 2-port switch. You could have your data come out and then your data continue on. You could plug in the data here and then chain it to the next one. For the panel chains, the way they work is each one of these rows is a different chain, and then it goes all the way down that way. So there's 8 chains of 7. So for example, this cord right here, which plugs into, I think, jack 1, is it? Yeah, jack 1 right here, goes up to here, and then it gives data to this panel, then goes to the next one, and the next one, and the next one, all the way down. And then this one is on J2, goes all the way down. This one's on J3, goes all the way down, and so on and so forth. Now for the power distribution side of things, this kit that I bought with Wired Watts included 7 of these fuse boards for power distribution. They say P10 right there, it's upside down, but it says P10. These work with P5 too, there's really no difference. The way these work is you have an input right here, 5 volts and ground, and then it goes to a power supply, and then it gives you 8 outputs, or 4 outputs. There's 8 different terminals, 4 power and 4 ground. And then I wired in these splitters that came with the Wired Watts kits. Each of these can control 2 panels. It has 2 different outputs, and your power plugs in to the middle of the panel here. So each of these can run 8 panels. That's why we have 7, because 8 times 7 is 56, and that's how many panels we have. The first 2 are over here, there, and there. And this power supply powers those 2 and the color light card. This power supply right here powers these 2. And then we had an odd number, so we had to put 3 of these fuse boards on 1 power supply. Now, other things on the inside here, like how it's held together, I have these Wired Watts panel mounting strips. These are the 8 tall ones. They have screws to put in every corner, so there's 4 panels that meet right here in this corner. And at the top of each of them and the bottom right there, there's a single screw that is screwed in to this board, and that's what holds this in. There's also a bunch here down the sides. These are the side mounting strips that came with the kit, and they go all the way down here. It holds it up pretty well. It is a little bit shaky inside, but not too bad. Another thing we have back here are these angle pieces right here to hold the corners together. We got these at Home Depot. They were made for a shelf. Now, if you're wondering how we held on all of the components back here, I'll start off with the power supplies. The power supplies came with these brackets. I'll show a picture of them on the screen. What you do is you screw the power supply to the bracket, and then these brackets screw between 2 panels. So if we were to put one like on these 2 panels right here, the top would screw into this hole and the bottom would screw into this hole. It comes with 2 holes on it, a big one and a small one. And if you look, the bigger ones are closer together. You should use the small ones to make it fit on here. The color light card was the exact same way, just a slightly different bracket. It also had the big holes and the little holes. However, the distribution boards did not come with any brackets, but these holes on the top and on the bottoms are perfectly aligned, so you could pick any one of the holes and put them into 2 screws on a panel like this. But that's everything on the inside of the panel that I wanted to go over. Now back to you, future Nick. Thank you so much, past Nick. That was an amazing video behind here. Don't talk about it. I know I'm amazing at this. The last final thing I want to talk about are these hooks we have up here. These 2 hooks, there's one there, and then there's one all the way down at the other end of the panel, right there. These are the other safety measure to make sure this does not tip over. So this is the garage right here where the panel is going to be sitting. It's going to be just under this part right here, and it's mostly going to be covered by this. But a little bit's going to be under here. And we have the little eyelets there, and we also have an eyelet here and right there. And we're going to take some sort of rope, maybe a little chain, something, and we're going to hook it between here and the eyelets on there just to help hold it. And this is very hard. Like, I cannot pull this out at all. So this is very sturdy. This is not going to be able to come out. The other thing I wanted to show is how much power on the AC side this thing takes when it's on full white. It looks like it's flickering right now in the camera, but it's not. It's actually just perfectly white. Nothing's happening. So it's probably something to do with the camera. But right back here where this cord is, all the panels are plugged into this one extension cord. This is the extension cord that the 2 AC cords are plugged into. And I have this little meter right here. And if we look at it, it is upside down, so I'll flip it over. But it's taking 5.88 AC amps with it on full bright white at 100% brightness. And now you can even start to hear the fans on the power supplies are kicking on. Because obviously this is taking a lot of power, but oh my goodness, my camera's going crazy with it. But it's because the power supplies need to output a lot of power to be able to make this. Now, before I ended the video, I wanted to show you what some videos look like on the screen so you can see how the resolution looks. But as you can see, it does look pretty good on the screen. You can clearly tell what it is. Yeah, it's pixely. It's like if you're watching something on your phone and you have barely any internet. But if you had P10 panels, this would be even more pixely. It would be half the resolution as this. So if you want to be able to play videos and stuff, I really recommend you have P5 panels. And also, all of the flickering you're seeing from my phone, that is not actually happening. It's just my phone trying to capture the video of this. The only thing that is flickering is right over here. There are a few lines of pixels that every now and then just flicker. That's been going on for a while, and I'm trying to find a way to fix that. I don't know if it's a setting or anything. So if you have any idea what this is, please let me know in the comments below and how I can fix it or what I'm doing wrong. Like always, if you have any questions or comments or know why these pixels keep flickering over here for absolutely no reason, please let me know down below in the comment section. I really appreciate all of your feedback, and I'll try to respond as soon as I can. But other than that, thanks for watching, and I'll see you in the next video.